an atom inventory, we are going not observing change, something totally different. But our objectives, we should recognize a balanced chemical equation, recognize an unbalanced one, and we should be able to balance a chemical equation if it's not already balanced. Okay? So the Haber process is how a guy named Fritz Haber, he was a German scientist, found out how to react hydrogen and nitrogen to produce ammonia. And the formula for nitrogen is N2. The formula for hydrogen is H2. And ammonia is NH3. So, does anyone see anything like that doesn't look right about this reaction up here? What about the 3? There's 3 hydrogens. There's 3 hydrogens in the products, but there's only 2 in the reactants. Do we think a nitrogen atom just became a hydrogen atom? No. That can't just happen. So what's wrong? Do you understand?
I think I know what happened.
What happened?
The N has a 1 in front and after it.
Well, we'll get there, okay? It does, you're right, but
Gotcha.
the problem with this is the law of conservation of matter, which we talked about last class or the day before that. We can't just create atoms out of nothing, and we can't get rid of atoms. So when we have N2 gas and H2 gas reacting, they form NH3 gas. But we have 2 nitrogen atoms in the reactants. Oh, here we have a model. We have 2 nitrogen atoms in the reactants and 2 hydrogen atoms in the reactants. But our product has 1 nitrogen atom and 3 hydrogen atoms. We can't do that. That doesn't make sense.
So does it just disappear?
Nope. We'll get there. Oops. So, how many of each atom? In our reactant side, we have 2 nitrogen atoms and 2 hydrogen atoms. Right? 2 nitrogen atoms, 2 hydrogen atoms. In our products, we have 1 nitrogen atom and 3 hydrogen atoms. So, we have different numbers of atoms in the reactants as we do in the products. This is an example of an unbalanced chemical equation. If we don't have the same numbers of each atom in the products and the reactants, it's unbalanced.
It wasn't the same thing as the other one, though?
So, since they're not equal, you guys just took this down, so you don't have to take it again. They're not the same. 2 nitrogen atom in the reactant, 1 nitrogen atom in the product, 2 hydrogen atoms in the reactant, 3 hydrogen atoms in the product. Not a balanced equation. Okay? Don't take this down again. You already have this down. So, in order to make a balanced equation, we need to add groups of each substance until we have the same number of each element in the products and reactants. Don't write anything down yet. Look up here. Everybody look up here. Eyes up here. Everybody look up here. Eyes up here. Okay. So, look up here. Okay. So, we don't have enough nitrogen atoms, so we have to add another group of nitrogen atoms. So make sure we have 2 nitrogen atoms in the reactants and 2 nitrogen atoms in the product. Okay? We have to add another group of hydrogen atoms because we have 6 hydrogen atoms in the products, but only 2 in the reactants. We have to add another group of 2 to get 6. So how many groups of nitrogen atoms do we have in the reactants? How many nitrogen groups of N2 do I have? Nope, I have 2 N2s?
1.
I have 1 group of N2. How many groups of H2 do I have? I have 3 groups of H2. And how many groups of NH3 do I have? 2. So in my reactants, I I have 2 N atoms and 6 H atoms. In my products, I have 2 N atoms and 6 H atoms. Am I balanced?
Yeah.
This is a balanced equation. So what I do, the balanced equation overall, I have 1 group of N2, 3 groups of H2. So I have, in my products, I have 2 groups of NH3. So a balanced chemical equation, look up here, everybody eyes on the board. Okay? I have 1 group of N2. I have 3 groups of H2, and I have 2 groups of NH3. That's where that's where those coefficients come from. Okay? And in a second, I'm going to go over a couple examples of balanced equations. You guys are going to copy it down. Okay? So let's copy these down. Don't do any balancing yet. I'll go over them in the class how I like to do them. Let's check out, this is what I do when I balance an equation. So the first thing I do is under the arrow, under the yield sign, I write the elements that we have in the equation. So in this case, we're talking about iron, Fe, and oxygen, O. Shh. So in my reactant side, how many Fe's, how many iron atoms do I have listed?
1.
1. How many oxygen atoms do I have listed?
2.
2. How many Fe in my products? 2. How many O's in my products?
3.
Okay. So I have to figure out a way to balance this out. Now, since I know how to do this, I'm going to say let's start with the oxygens, because those are going to be a little more challenging to balance out with. I can come back and do my Fe's after. So what coefficients could I put in front of here to have a common multiple? I have 3 oxygens here, 2 oxygens here. What are common multiples that I could make it so they would be equal? What would I have to do, Brandon? What's that?
Hydrogen.
Multiply what by 2? If I have 2 of these and 3 of these, 2 of these, what does that change? How many Fe's do I have now? Now I have 4 Fe's here. How many O's do I have? 6 O's here. Now I have 6 O's here. I have a common multiple. I can make that here. How many O2's do I need to get 6?
3.
I need 3 of these. That changes the O right here, so I have 6. Now, what's the last thing I can do here to make the Fe's balance out? I need 4 Fe's here. Am I a balanced equation? Good. Okay, makes sense? Let's go over this next one right here. Here I have 3 elements: carbon, hydrogen, and oxygen. So let's do a tally. How many carbons do I have in my reactant side? CH4. How many C's?
1.
I only have 1 C here. The 4 applies to the hydrogen only, not the carbon, because this is carbon and hydrogen are separate elements. How many H's do I have? 4. How many O's? O2? I have 2. How many C's on my product side? Sweet. How many hydrogens do I have on my product side? 2. How many oxygens? I have 2 here. 2 here with this O2, but I have 1 more here with H2O. So I have 3 total. So let's pick something to balance. Now, my carbons are already balanced, so let's move on to hydrogens. How can I make this have the same number of hydrogens in the products as I do in the reactants? What do I have to do?
Times by 2.
I have to have 2 H2Os. I have to multiply it by 2. What does that change? Now I want to retell it. Now I have 4 hydrogens. Am I balanced equation yet?
No.
No. What else does this change?
No, a top one, isn't it?
I have, not only does this change the hydrogens,
Oh, it changes
but it
this
also
one. Oh,
changes the oxygens
yeah.
here. How many oxygens do I have total on my product side?
5 now.
Nope. I have 2 H2Os. How many O's is that? How many O's here? I have 2 O's here. How many O's?
So you have 4.
And I have 2 oxygens here. So I have 4 O's total. Now, what can I do to make this an overall balanced equation? It's pretty easy now.
Put a 2 in front of the O.
Put a 2 in front of the O2. What does that change?
That. So,
Yep. So now I have 4 O2s here.
And now it is.
Now we are balanced. Now, one thing that I don't mind if we do, if you guys are having problems, if you guys want, you guys can write 1 and 1. I don't mind if you guys want to put the 1 coefficients in there. It's fine. If you don't write anything, we will assume it's 1. It's understood as 1. 1 is understood. You'll see that a lot in chemistry, kind of how if there's nothing written CH4, 1 is understood to be there. So,
yeah.
I'm playing Russian roulette. I haven't got one yet.